Okay, hi Cass. I'm going to start with the derivative questions from the test or from the quiz. So I just went through and I looked at the topic for each one, and I'm not going to start with number 5 because that's a related rate, so I'm going to go back to that. So I'm going to start with number 7. Pardon me. Number 7 said the minimum value of f of x equals e to the x minus 2x is what? So if they want a minimum, the first thing I'm going to do is take a derivative. And so all right, when they want a minimum, they're asking you, basically they're asking you what the smallest y value is. So in order to find that, we got to find out where the min happens. So mins happen when the derivative is 0 or undefined, and then the derivative changes from negative to positive. So I have to take the first derivative. So I take the derivative of this, I'm going to get e to the x minus 2. And I have to set that equal to 0 and solve. So I'm going to add 2 to both sides. I'm going to e to the x equals 2. And I have to solve that for x. So log formulas or log rules, because x is in the exponent, I would take the natural log of both sides. And I'm going to do that so that this exponent will become a multiplier. And then the natural log of e is 1. So this is x times 1 equals the natural log of 2. So there's my answer for x. And it looks like that's what you put for your final answer. But this is just the critical value. This is the x value of the critical value. If they want the minimum, they want to know what's the y value that goes with that x value. So because I only got one answer, I don't even really need to test it. I could make a number line with the natural log of 2 and look at the derivative and make sure the derivative changes from negative to positive because this needs to be a min. But unless one of my answers was like there is no minimum value or something, I wouldn't even go make a number line. I would just assume that the number you got is the place where the minimum happens. So that's the only thing that's tricky about this is I need to know not just the x value, but where does the, or I'm sorry, what's the y value that goes with that x value? Oops, sorry, I didn't realize this was off. So to find the y value that goes with that x, I got to go back to the original. The original question is f of x is e to the x minus 2x. I need to plug in the natural log of 2 for x. So I'm going to get e to the natural log of 2 minus 2 times natural log of 2. That could be fine for your answer. This is the y value. This is the minimum value. Oh my gosh. Sorry, I keep being off here. I hate this tripod thing. This is the minimum value, but it was multiple choice and I don't think the answer looked like that. So a couple other log rules. E to the ln 2, when I have that, that's just going to equal 2. So just to keep in mind, a log rule is that like 5 to the natural log of, I'm sorry, not 5. E to the natural log of 6 is going to equal 6. Or e to the natural log of x is going to equal x. That's kind of a shortcut for what happens there. So anyway, e to the ln 2 is just 2. So this is my answer. Your multiple choice might not have even looked like that. This would be 2 minus, I can pop this up as a power. That's another log rule. So 2 minus natural log of 2 squared, which is 2 minus the natural log of 4. That's probably what the multiple choice answer was. So again, the only calculus thing to pick up from this is when they want the min value, they want the y value, not the x. You answered the x. So you have to go back and plug that into the original, in which case here there are a few log rules to have remembered from pre-cal and whatnot. But so that makes that kind of hard. But so that's number 7. Let me flip my page. Okay, so number 9 on here was a kind of funky question, but it was a chain rule question, and it's definitely one that I could see coming up on the exam or even on the one you'll be taking from me. So this is number 9. So number 9 said if the derivative of f was x minus 2 to the third, squared times x squared minus 4 over 16. And g of x is f of x squared minus 1. What is g prime of 2? So I'm going to have to figure out what g prime of x is first of all. So I have all this crazy stuff. I have this function that's the derivative of f, and I have this function for g, and we want the derivative of g. So, okay, so this is a classic chain rule problem. So to remember just chain rule in general is like if y equals f of g of x, the derivative of y would be take the derivative of the outermost thing with respect to what's inside times the derivative of what's inside. So the way that looks is the derivative of whatever's outside with respect to what's inside, leave g of x alone, times the derivative of what's inside. That's chain rule in its like written out form. So again, I'm taking the derivative of the outermost thing with respect to what's inside times the derivative of what's inside. So if I could apply that to this kind of problem, if g of x is f of x squared minus 1, the derivative of g is the derivative of f with respect to x squared minus 1 times the derivative of x squared minus 1, which is 2x. So that's chain rule applied to that problem. The derivative of the outside function with respect to what's inside, leave that alone, times the derivative of what's inside. So if they want g prime of 2 for this problem, I'm going to plug 2 in. So I'm going to find the derivative of 2 squared minus 1, so 3, times 2, which is 4. And I need a value for this, which I'm going to get from up here. That's where that comes in. So f prime of 3, if this is f prime, I'm plugging 3 into this whole big thing. So I'm plugging 3 into here. So 3 minus 2 is 1. 1 squared is 1. And then 3 squared minus 4, so it's 9 minus 4, so it's 5 over 16. So this is 5/16 times that 4. So 20 over 16 or 5 over 4. Right, there's so much going on that problem that is, this is a good one to go through and understand. And let me know if you're like, I'm still not really sure. I can come up with some other examples of that. In fact, here, let me just throw one in here. Well, we'll see them as we review. I don't know if I'll be able to come up with a very good one off the top of my head, but that's the way that that's handled, number 9. All right, number 10. Number 10 said, where does a graph have horizontal tangent lines? But the curve was given to you like this: y squared minus x to the third minus 15x squared equals 4. So 10 said, where does this have horizontal tangent lines? So that means we have to take the derivative of this and set the derivative equal to 0. That's where horizontal tangent lines happen, when the derivative is 0. So you have to take the derivative of this, but the x's and y's are mixed. So this is called the implicit differentiation. This is one you could look up on Khan Academy. Like if you used implicit differentiation, they would have practice for you. So, you know, after this, that might be something you want to practice. I'm sure implicit differentiation is going to show up on the AP exam as well. So to take the derivative of this function, whenever there's x's and y's all mixed up, every time you take the derivative of a y, you're going to do the derivative normal, but you're going to chain on a y prime. And every time you take the derivative of an x, you don't have to do that. So to take the derivative of this, the derivative of y squared is going to be 2y, just like normal, like there was nothing to worry about, times y prime. Minus, keep going. Now I don't have any y's left, so this is just going to be 3x squared. This is going to be 30x, and the derivative of 4 is 0. So to find out what, I had to set the derivative equal to 0. Well, to find out what the derivative is, I have to solve for y prime. So I'm going to add this to the other side. I'm going to add that to the other side. And I'm going to divide by 2y. So this question asked, when is the, for what values of x does the curve have horizontal tangent lines? So that means, when is the derivative equal to 0? Well, this is the derivative. I don't care about the bottom being 0. That doesn't that won't tell me where the derivative is 0. I just want to know when is the top equal to 0. So I'm going to solve this. I'm going to factor out a 3x. I'll be left with x plus 10 equals 0. And I get two answers, 0 and negative 10. When you answered this, you said 0, negative 10, and also positive 10. I'm not sure where the positive 10 came from, but it's just those two places only. Okay, I think that's it. All right, so there was one other question from the test, and that was a related rates question. It was number 5. So the thing with related rates, I'm still going to probably tell you not to waste too much brain space on it. But the circuit that was posted, which I don't know why it didn't work for you. I guess I hopefully posted the picture of the problems as well. But if I didn't and you need it, let me know. Anyway, so this was the circuit that was posted. These are the answers to it, which I'll slow down in a second. But in terms of related rates, the problems that would be important for you to know would be the two at the bottom here. So it doesn't seem like they're related rates, but they are. They're basically taking derivatives with respect to time, which is kind of the point of related rates in a way. So let me pause on it. I know my work is on it right now and I don't have a clean copy, but a particle is moving along a curve with dy dt equals 1/4 and y equals the cube root of x. Find dx dt when x equals 2. This is the setup for a related rate type problem. They're not making you figure out everything, but basically they're saying you're given that dy dt is 1/4. You're also given that y equals the cube root of x, and you're asked to find dx dt when x equals 2. This is a good question to do as well before you really get into related rates, because it puts everything together without having to synthesize information from an actual problem. So when you get a related rates problem, this is basically what's happening. They're going to give you a certain rate. You're going to come up with this formula usually it's volume or surface area or something. And then they're going to ask you to find some rate of change when one of the variables equals something. So I think the problem that you had was find the rate of change of the surface area when the radius is 5. So they're just saying now find the rate of change of x when x equals 2. So to do related rates, whatever formula I'm given or that I had to come up with, whether it was volume, surface area, or whatever, I'm going to take the derivative of it. But when you take the derivative, you're going to take the derivative with respect to time. That means that so when I just did the implicit one, every time I took the derivative of a y, I needed a y prime. That's because technically I was chaining on a dy dx. And every time I took a derivative of x, I didn't need it because technically I have a dx dx, which is just 1, so I never needed it. But now that I'm taking derivatives with respect to time, any variable that's not t needs a chain. So when I take the derivative of this, the derivative of y is just 1, but times y prime, or dy dt. When I take the derivative of the other side, this is x to the 1/3. I do the derivative 1/3 x to the negative 2/3, but then I have to multiply by the derivative of x, which is dx dt. If the dt thing is annoying, you could also think about this as 1 times y prime equals 1/3 x to the negative 2/3 times x prime, and understand that the y prime is really dy dt and x prime is really dx dt, the derivatives of that variable with respect to time. So that's what's happening with the derivative part. So now dy dt, I can put that value in. I have this value. I have x equals 2 at that moment. And dx dt I don't have. That's what I'm trying to solve for. So with related rates, you're going to plug everything in, and hopefully you'll have a value for everything except the one unknown that you're looking for. And then you're trying to solve the problem. This is a little annoying in terms of the computation. So this is 1/2 to the 2/3. So 2 squared is 4, so it's the cube root of 4 times x prime. And then you could go look at I solved it by saying, okay, x prime is going to equal 1/4 times 3 times the cube root of 4. And I think I reduced it even more. But there's your basic answer. So there's a second question like that. Here's the second question. If you want to even like pause it, try it, and then check my answer. This one doesn't have as much crazy computation. So I think for now, there's so much work and so much that gets piled up. This is the circuit. This is page 1. I would make sure you're comfortable with these two. Oh, mean value theorem, I'll go over that in a second. And then here's the second page. A lot of the problems are repeats because the circuit was kind of weird. So, you know, pause it or whatever. Was there a mean value theorem on here? So there was one mean value theorem. I was trying to find it. Oh, it's down there. I can also do it here. So here's the mean value theorem. Here's a picture of that problem. I'll go through that with you now. So mean value theorem, the only thing you really need to know is that like mean value theorem is basically just saying if you have some curve and you have endpoints of the curve, like here and here, you just want to find the slope between those two endpoints. Like if this is like x1, y1, and this is x2, y2, you want to find the slope between those 2 points, like y2 minus y1 over x2 minus x1. And the slope between those 2 points, you're going to set equal to the derivative of the function, and you're going to solve. Mean value theorem is just saying, find the slope between these 2 points and figure out where on the curve the derivative is the same. So basically, where is the slope of the tangent line the same? So like if the slope between these 2 points is, you know, 1/3, somewhere along here, the slope of the tangent line will also be 1/3. And to find that, you're going to find the slope between the 2 points and set that number equal to the derivative of the function. So in that problem that I just showed you over here, apply the mean value theorem to the function on the interval 0, 2. Find the x value where the guaranteed value of the derivative occurs. So what they're asking you to do here is find the slope between not these 2 points. This is an interval. So we have 2 points, 0 comma something, 2 comma something. Find those 2 points. So plug 0 into the original and I get 3. Plug 2 into the original and I'm going to get 3 plus 48 minus 8. So 43. Mean value theorem says find the slope between these 2 points. So 43 minus 3 over 2 minus 0. 40 over 2 equals 20. So that's the slope between those 2 points. So whatever this curve looks like, that's the slope between them. Now find the derivative of the function. So 24x minus 3x squared. Set the derivative equal to that slope and solve for x. That's what they want you to do for mean value theorem. So take 24x minus 3x squared and set it equal to 20 and solve that. So I would bring everything to one side. 3x squared minus 24x plus 20 equals 0. And solve for x. I'm going to get 2 answers. Whatever those 2 answers are the 2 places on the x-axis where the function is going to have a slope of 20, which will match the slope of the endpoints. But if the y is confusing to you, don't worry about it. Take the interval, those are 2 x values, plug them into the original to get the y's, find the slope between the 2 points. Set the derivative equal to that slope. And that's how you find the x values they're talking about. So anyway, I hope that helped clear up stuff and things make more sense. I wish I had more practice. this stuff's going to come up over and over again. So maybe label your notes. Take this out of here. Maybe label your notes with like related rates, mean value theorem, implicit differentiation, maxes and mins. So like when a problem comes up later, you can go to them and be like, okay, here's what I did here or whatever. It's a lot, I know. I'm proud of you and thanks for reaching out, and just keep on keeping on. And I think that when you get problems next week that refer back to it, you'll be able to go back and be like, okay, now I know what I'm supposed to do for this. So anyway, I don't know. We'll see. All right. Bye, Cass.